The founding ethos of Elon Musk's private spaceflight enterprise SpaceX was to make life multi-planetary. He claims that relocating people on other worlds such as Mars may save civilization in the event of a calamity on Earth, such as a massive asteroid strike. The billionaire is a huge fan of the Voyager spacecraft and has discovered a surprising revelation made by the two spacecraft. What have the twin Voyagers uncovered this time? How long can they hold out in interstellar space? In this video, we show you how Elon Musk recently unveiled Voyager's alarming new space discovery. The SpaceX founder has frequently expressed his desire to develop settlements on Mars. He believes that settlements will require a significant number of people to become self-sustaining. Realizing this ambition necessitates the use of a capable vehicle. The Starship is a rocket and spacecraft combo that can transport more than 100 people to Mars at once. The system is intended to be completely and rapidly reusable. Being fully reusable implies that the main hardware pieces are not abandoned in the water or allowed to burn up, as some other launch systems do, but instead return to the ground and can be flown again. Rapid reusability means that after returning from orbit, Starship can be refueled and ready to launch again in a short amount of time, much like an aeroplane. This lowers the overall cost of the company. However, before all of this, Elon Musk was a skinny 6-year-old boy when NASA launched the two Voyager probes. Nevertheless, as an adult, Musk and the Voyagers have a lot in common. Musk, for example, currently launches commercial rockets from Cape Canaveral in Florida, where the iconic Voyagers took off. Even though Musk has reached the age of 50, it is nothing short of astounding that the two spacecraft are still operating in space. Few people expected the mission to endure decades when it was launched. The planners were happy with a 4-year objective. However, owing to these tenacious spacecraft, we continue to learn new things about the far-flung universe. Many people may not realize it, but the Voyagers would not have launched if the stars had not aligned. Literally, the stars in this case were the solar system's 4 biggest planets: Jupiter, Saturn, Uranus, and Neptune. The last time this happened was during Thomas Jefferson's presidency in the early 19th century. The alignment of the 4 planets meant that spacecraft would benefit from the gravitational pull of each big planet they passed. It's as if the spacecraft were being dragged along by an unseen cord that snapped at the last second, propelling the probe on its course. NASA scientists projected that recurrent gravity assistance would reduce the trip time between Earth and Neptune from 30 years to 12 years. There was only one catch. The alignment only happens once every 176 years. So in order to assure that the spacecraft reached the planets while the lineup was still active, a spacecraft would have to be launched by the mid-1970s, which NASA did. To fully capitalize on this once-in-a-lifetime chance, NASA developed 2 spacecraft rather than 1. Each is around the size of an earlier Volkswagen Beetle and is identical in every manner. NASA outfitted the Voyagers with onboard intelligence to manage all of the tasks anticipated by the probes. This was essentially a computer with just 69 kilobytes of memory, which is less than 100,000 times the capacity of a regular smartphone. When a key fob used to unlock the automobile door has more memory, comparing it to a smartphone is inappropriate. All data acquired by the spacecraft instruments would be saved on 8-track tape recorders before being sent back to Earth using a 23-watt transmitter the size of a refrigerator light bulb. To compensate for the poor transmitter, both probes use 12-foot wide dish antennas to transmit and receive signals. Since their launch in 1977, the Voyagers have made several discoveries, but what has allowed them to continue operating to this day? Voyager 1 currently holds the record for the furthest distant man-made object from Earth in interstellar space, billions of kilometers away. Receiving signals from the spacecraft takes roughly 2 days, and it is currently in one of the toughest environments in the cosmos, with extremely frigid temperatures and pitch-black darkness. It also includes a high level of radiation, so not only do the scientific instruments on board require power, but the spacecraft must also keep itself warm in the frigid atmosphere of space. Because the sun's rays do not reach these spacecrafts at their location, they must rely on radioisotope thermoelectric generators, or RTGs, for energy. Each of the Voyager probes contains 3 RTGs, which use plutonium-238 as a fuel source, producing heat that is converted to electrical energy when the isotope decays. Each Voyager was launched generating 470 watts at 30 volts DC. However, the problem is that it decreases with time. However, that is only one of a few viable options for powering the spaceship for decades. After 546 days of journey, Voyager 1 arrived at Jupiter in March 1979. Voyager 2 actually launched a few weeks before Voyager 1 and took a different path, arriving in July of that year. Both spacecraft were built to provide a sturdy foundation for its Vidicon cameras, which employed red, green, and blue filters to generate full-color images. While moving through space, the Voyager spacecraft do not spin much. In fact, their rotational speed is more than 15 times slower than the creep of a clock's hour hand. This is a purposeful design decision to reduce the possibility of fuzzy images. Voyager 1 began broadcasting images of Jupiter while it was still 3 or 4 months distant from the planet, and the sharpness and detail were remarkable. The images of Jupiter's moon have utterly surprised astronomers due to their unexpectedly brilliant look. Prior to the Voyagers, it was assumed that all solar system moons, like the Earth's moon, would be more or less similar. Nobody expected the Voyagers to encounter such a diverse range of moonscapes surrounding Jupiter and Saturn. While more than 1 million miles away from Jupiter, one of its equipment, the Low Energy Charged Particle (LECP) detector system, picked up what scientists believe were strange signals. They began to see oxygen and sulfur ions striking the detector. The density of oxygen and sulfur ions had increased by 3 orders of magnitude compared to previous measurements. The crew initially believed the equipment had malfunctioned, but upon closer inspection, they discovered there was nothing wrong. Scientists were able to answer one issue owing to the Voyager cameras, whether Io has active volcanoes. The Moon, which is slightly larger than Earth's moon, has been verified as the solar system's most volcanically active body. Prior to that time, the only active volcanoes we were aware of were on Earth. However, Io had 10 times the amount of volcanic activity as Earth. The hues of Io and the unusual ions striking the detector were caused by elements ejected by the Moon's volcanoes. Pele, the greatest of Io's volcanoes, has thrown off plumes 30 times the height of Mount Everest. Pele debris spans a region about the size of France. The cameras on the Voyagers alone captured almost 33,000 photographs of Jupiter and its satellites, the majority of which revealed previously unknown information. Jupiter, for example, had rings, and Europa, one of Jupiter's 53 named moons, was covered with a fractured ice shell that was now believed to be more than 60 miles thick. The 2 Voyagers parted near Saturn, with Voyager 1 racing through Saturn's rings and passing Titan before turning north away from the planet's plane. Voyager 2 then moved on to Uranus and Neptune, where it discovered 10 new moons and added Uranus to the expanding list of ringed worlds. 3 years later, Voyager 2 would reach 2,980 miles above Neptune, when it recorded the fastest wind ever recorded in the solar system, 1,000 miles per hour. It also identified Neptune's biggest moon, Triton, as one of the coldest spots in the solar system, with a surface temperature as low as minus 235 degrees Celsius. 5 miles into the atmosphere, an ice volcano ejected nitrogen gas and powdered particles. Voyager 1 is responsible for one of the world's most famous photographs, which would not have been possible without the persistence of eminent astronomer Carl Sagan. After seeing the images of Neptune and its moons, NASA was ready to turn off the cameras on both spacecraft, despite the fact that the mission had been extended in the expectation that the Voyagers would reach interstellar space. They had determined that there would be no images after Neptune, since there was nothing but an unending nothingness and incredibly distant stars all around. Sagan, on the other hand, appealed with NASA to have Voyager 1 deliver one last set of photographs. On Valentine's Day 1990, owing to his persuasion, the spaceship pointed its camera back toward Earth and snapped 60 final shots. The most striking of them was the pale blue dot, which captured the Earth from a distance of 3.8 billion miles away. That image is still the most distant depiction of our planet ever captured, shrouded by a single ray of sunshine reflected from the camera's optics. Our planet is scarcely visible in the photograph. It doesn't even take up a complete pixel. The Voyagers are still in communication with the control center, but they recede by 3 to 4 light seconds per day. NASA's Deep Space Network, which comprises of 3 monitoring complexes placed around the Earth, allows scientists to communicate with them. Both explorers have now passed through the heliopause as they continue their trek out of the solar system. Voyager 1 passed by in August 2012, while Voyager 2 did so more than 6 years later. However, the 2 spacecraft might still surprise their operators. For example, earlier this year, NASA discovered Voyager 1 was sending back unexpected data. The Attitude, Articulation and Control System, or AACS, of the probe regulates the spacecraft's orientation, the alignment of its high-gain antenna toward Earth, and attitude movements. Now, the AACS has returned data that NASA experts claim does not accurately reflect what is happening aboard Voyager. They aren't even sure if the data was created at random. Despite its age, NASA maintains the Voyager 1 functions well for the most part. Therefore, the crew in charge of the spacecraft is attentively monitoring the signals to establish whether the erroneous data is coming straight from the AACS or from another system engaged in creating and relaying telemetry data. They may be able to resolve the issue with a software update. The Voyager spacecrafts will continue to cruise across space and will be there long after humans are gone. Please share your thoughts on the Voyagers in the comments section below.